Namaste to everyone. Welcome back to another session of Science at Your Tips. In this session, we are going to discuss some of the organic compounds, names in IUPAC system, and that too, their formulas are not given for us, but just lines are given. This is known as line system of organic compounds. Just by observing the lines, we have to identify what is that compound. We should be able to find out how many number of carbons are there. So here carbons and hydrogens will not be seen, which is a part of hydrocarbon. If any functional group is there, that functional group will be seen, like OH for alcohol, COOH for acids, carboxylic acids. If it is a ketone, oxygen, or if it is a aldehyde, oxygen will be seen. If any halogen is there, that also will be seen, but carbons and hydrogens will not be seen here. So how we are going to identify? Let us check the rules and regulations to identify the type of the compound here. Here the lines will be written in the form of zigzag fashion. By observing the lines only, we should be able to identify the number of carbons. Here hydrogens are not written, but they are assumed. Hydrogens are there, that is understood. Hydrogens will not be written. If it is a part of hydrocarbon, children, remember that. If it is a part of functional group like OH, COOH, then hydrogens will be written. Otherwise, if it is a part of hydrocarbon, it will not be written. Just they are assumed. And if any terminal point we are getting, that is understood as methyl CH3 group. If you are having some intersection which is not having any substituent, unsubstituted intersection is there, that is understood as CH2 group. One hydrogen has gone. CH3 means ending point, in the middle somewhere we are getting. Now let us take like this. If you are having some point, now this both the ends are understood as CH3, so this will become ethane. Endings are understood as CH3, so CH3 means C2H6. This is understood as ethane. If you are having some unsubstituted intersection, means this part will be understood as CH2. Now this structure, if you take CH3, CH2, CH3, that means it becomes C3H8, that is nothing but propane. Like that we have to identify. If you have a single line, that is understood as single bond. If you have a double line, parallel line, two lines are there, parallel lines, that is understood as double bond. Now if I take here single line, single bond, I have written this part. So this is understood as ethane. Then what about this? This is understood as ethene or ethylene. Common name is ethylene. Because endings will be understood as CH2 here. Understand this. Double bond between carbons, double bond is there, means CH2 double bond CH2 is possible. CH3 double bond CH3 is not possible, no. So that should be understood by you. Then if you are having three parallel lines, what we have to understand, that as triple bond. Now if I take triple bond like this, this is understood as CH triple bond CH. Hydrogens are assumed here. So this is a ethyne. Ethyne or common name acetylene. So acetylene, ethene, ethane, like that. So single bond, single line is nothing but single bond. Two parallel lines are there, double bond. Three parallel lines are there, triple bond. Okay, these rules and regulations you remember, because anyway functional group will be seen. By that we can understand. If any cyclic group is there, that also can be seen there. We can understand that. Just by practice we will get it. So let us see some examples here, how to write the name of the compounds if they are given in the form of a line system. Now this one, what we have to write? We are understanding this as CH3, no? So what we will write here? Ethane. Yes, ethane. What about this one? CH3, CH2, CH3. Understand this as CH3, CH2, CH3. Ending is understood as CH3. This will not be written here, but we are going to understand this. CH3, CH2, CH3 means this is nothing but propane. Okay. So this is understood as propane. This is propane. Hydrogens are understood, are assumed. Then what about this? How many carbons are there here? Let us count. 1, here 2, here 3, here 4. So 4 carbons, there is no double bond, there is no triple bond. 4 carbons means it will be a alkane which is having the formula C4H10. C4H10 is nothing but butane. Yes, this is nothing but butane. Then what about this compound? Here again we'll count the number of carbons. How many are there? 1, 2, 3, 4, 5. Total number of carbons here we have 5 without any double or triple bond. So we are going to write this compound name as pentane. 5 carbons are there. Root word will be written as pent. Ane is the suffix. So pentane. Let us see some more examples, children. Here this is a cyclic compound. For any cyclic compound, some prefix will be written. Primary prefix will be written. That primary prefix is nothing but cyclo. So we'll write this compound as cyclopropane. How this propane name came here? Here intersection, unsubstituted intersection will be written as CH2. It is understood as CH2. So what we will do here? CH2, 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 CH2. So at the ending means at this corners we are understanding this as CH2, no? So what we will do here? We are going to write this as cyclopropane. Cyclopropane. Okay. So CH2, CH2, CH2. 3 CH2 groups are there here. 3 CH2 groups are there here. So that's why we are going to write this one as cyclopropane. Cyclopropane. Then next one. Yeah, you can say this. 4 carbons are there. Cyclic compound without any double or triple bonds. So cyclobutane. Then this one. Yes. Cyclopentane. Then what about this? Double bond we got. Previously already we have discussed in the rules only. CH2, CH2. Between that double bond is there. Why I am saying CH2? Terminals actually CH3. But when double bond is there, it's not possible to have CH3, no? So CH2 double bond CH2 means it is understood as ethene. Can be identified as ethene. A UPSC system. Common name if you want to write, you can write ethylene. Then what about this, children? You can write this as propene. 3 carbons are there. Prop, root word. Double bond is there. Ene, suffix. So altogether propene. Then this one. Here double bond is present. Okay. 4 carbons are there. Butene. Okay. But we have to mention the locant. We have to mention the carbon on which double bond is present. So if you are having a double bond on the second carbon, we are going to write this as but2ene, or simply we can write 2-butene. But2ene or 2-butene. Then what about this? We have here altogether 5 carbons. 5 carbons, just count. 5 carbons are there. Every ending unsubstituted intersection is understood as a carbon, no? Hydrogens are assumed anyway. So if you count that, we are getting 5 carbons and a triple bond is there on second carbon. So we can write this as 2-pentyne. 2-pentyne. If triple bond is present between third and fourth, can we write that as 3-pentyne? 3-pentyne is not possible. 3-pentyne, children, once you see, because if you are having this triple bond on second carbon means a third and fourth carbons. If you want to write that one, what we will do here, if I am writing in this form, here altogether 5 carbons are there. Now I'll take this now I'm going to write triple bond here. Can we take this as third carbon and this as fourth carbon? No. You have learnt already least number of locants, least set of locants. So according to that we have to start counting from this side. So first carbon this one, this is second carbon. So again it is becoming second carbon only. So let us write this as 2-pentyne only. In this form or that form 2-pentyne. 1-pentyne is possible but 3-pentyne is not possible. 2-pentyne we can write. Then this one cyclopropene. 3 carbons are there, a double bond is there. Then what about this cyclobutene? No need to mention the locant because from anywhere if you count it will become 1 only, because wherever double bond is there that carbon only should be given the least number, no? So cyclobutene, cyclopentyne, 5 carbons are there, triple bond is there. If it is open chain, we have to give the numbering compulsory for butene, pentyne or pentene, whatever. But as it is present in cyclic compound, cyclic form, closed chain, we are not going to give the number here. If any other substituents are there, then compulsory we have to mention that number, mention the locant, means on which carbon that particular functional group is there, triple bond, double bond is there, that we have to mention. Here, no need. Here, no need. Then what about this? We have here 5 carbons, 2 double bonds are there. So what we will do, we'll give the numbering for this carbons. So first carbon let me take, because I have to start from the carbon wherever double bond is starting. I'll do in 2 manners. Whatever I do, I will get the same name. Now let us try to write the name penta 1,4-diene. Penta 1,4-diene. But cyclo compound is there, so cyclopenta 1,4-diene, it's okay. But I don't want to write like this. I wanted to write in another manner. So what I will do, I'll just remove these numbers. I'll just remove these numbers and I'm going to write in another manner. You may be asking me why you are going in a clockwise manner only. You can go for anti-clockwise. So from here I'll start 1, 2, 3, 4, 5. Then you just see 1, 2, 3, 4, 5. Now what is the name you are giving? 1, 1, 3, diene. So instead of writing 1,4-diene, 1,3 we can write, no? So instead of writing this name, we can write cyclopenta 1,3-diene. Least locant or lowest sum rule already we have seen. So let us write cyclopenta 1,3-diene, not 1,4. Okay. So we have to do in different manners. How we are getting lowest sum rule, least locant rule, all that we have to check. Then next one. What about this? Again we can give the numbering. Wherever you give the numbering, like I want to give the numbering here. From here onwards I want to start. So first, second, third, fourth, fifth, sixth. Okay. Now first carbon, double bond is there. Third carbon, double bond is there. Fifth carbon, double bond is there. So 1, 3, 5. Double bond means ene. 3 double bonds are there, triene. Cyclic compound, cyclo. So on the whole, cyclo hexa 1,3,5 triene. Cyclohexa 1,3,5 triene. Like that we can write. Okay. Then coming to this compounds, here we have 3 compounds. How to give the name for this? Just see how many carbons are there. In the first one we have totally 6 carbons. 6 carbons are having some substituents are there. Methyl group, both the substituents are same. So dimethyl we can write. And where they are present, we have to give the numbering for this 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. From anywhere if you count, third and fourth carbons are having the numbering. So we can write 3, 4 dimethyl hexane. It's not a cyclic compound, children. Open chain, no? So 3, 4 dimethyl hexane. Second one, 5 carbons are there. If you start giving the numbering 1, 2, 3, 4, 5. So on second carbon methyl is there. If you give in another manner, again it will become fourth carbon. That is not the correct process, no? So 2-methyl pentane is the name for second compound. Third compound 1, 2, 3, 4, 5. Totally 5 carbons are there. In these 5 carbons, 3 substituents are there. All the 3 are similar. Methyl. So trimethyl pentane. But trimethyl means on which carbons they are present. Methyl groups are present in on which carbons. That number also we have to give, no? So 2, 2, 4, 2, 2, 4. 2,2,4 trimethyl pentane. 2,2,4 trimethyl pentane will become the correct answer for this. Then coming to the next compound. This is a cyclo compound. 4 carbons are there. So cyclobutane. Again OH group also is there. So that's why what we will do here, we are going to write this as secondary suffix. This secondary suffix we are going to write in the form of ol. Alcohol, no? Ol. So cyclobutane ol, cyclobutanol. That is the name for this. Then what about this? Here 5 carbons are there, chloro group, bromo group, both are there. So every time halogens will be written as prefix only, secondary prefix only, not as a suffix. Chloromethane, bromoethane, like that, not ethyl bromide. Ethyl bromide or methyl bromide means that is common name. IUPAC system, every time halogen will be written as a prefix only, secondary prefix. So bromo is there, chloro is there. So we have to give the numbering for the carbon on which this bromo is present, because we have to give the we have to see alphabetical order also, no? So 1, 2, 3, 4, 5. 5 carbons. So on first carbon bromo, third carbon chloro. So we can write 1 bromo, 1 bromo. It's not 2 chloro, no children. We have to write this as 3 chloro. We have to write this as 3 chloro, not 2 chloro. So what we can write? 1 bromo, 3 chloro, 1 bromo, 3 chloro, cyclopentane. Not 2, this is 3. 1 bromo, 3 chloro, cyclopentane. Then coming to next one, we have here 1, 2, 3, 4, 5. 5 carbons in the main chain, and one more substituent is present, CH3, and double bond O means keto group, Br means nothing but bromine. Bromo is there, keto group is there. Again keto means we have to write this as secondary suffix only, on. Then CH3 group also is there. So first of all let us identify this as a ketone only. So here how many carbons in the keto group? 1, 2, 3, 4, 5. So pentanone. In this pentanone also second carbon is having double bond O. So 2 pentanone. In this on first carbon we have bromine. Then third carbon we have CH3 group. Okay. So based on that we can write 1 bromo 3 methyl pentanone 2 or pentane 2-one. In any manner we can write. The next one. Here we have 1, 2, 3, 4, 5, 6. 6 carbons altogether. In these 6 carbons, now can we take 6 carbons or 5 carbons? Here we have to see that all the functional groups should be present in the main chain. Functional group in the sense not only alcohol, acid like this, but even we have to check. Double bond, triple bond also. So what we are going to do? This will be taken as the main chain. This will be taken as the main chain. So 1, 1, 2, this is second carbon, then third carbon, fourth carbon, fifth carbon, like this. So if you count like this, here on second carbon we'll be having the ethyl group, third carbon we have the methyl group, first carbon, fourth carbon have the functional groups double and triple bond. So 2 ethyl, 3 methyl, 1 pentene, 4 ine. Or we can write in another manner, children. 2 ethyl, 3 methyl, pent 1 ene, 4 ine. Pent 1 ene, 4 ine. Okay. So we have to see that all the double, triple, any functional groups, all that should be present in the main chain only, longest chain. Here we are not going to check the longest chain. Functional groups should be present in the main chain. Like that we have to take. Then next, here we'll count the number of carbons. How many carbons are there totally? 7 carbons are there. So what we will do? Double bonds wherever they are there, from that side we'll start counting first. That side numbering will complete first. After that only we'll go to the another side. If I give in anti-clockwise manner, no, again here any double bond is not there. So again numbering, least sum rule will be violated. So first carbon to 7th carbon. So okay, 1 minute. Here we can do in another manner, children. Double bond cannot be present between first and 7th. So what we'll do? We are going to give the numbering in another manner. What is that manner? Here we'll start counting from here. 1, 2, 3, 4, 5. Then this is a 6th one. This is a 7th. Like this if I give on first carbon, third carbon, fifth carbon, we have double bonds. So cyclohepta 135 triene or 135 cycloheptatriene. Mostly we'll be writing after hepta 135, or in some of the books you can find in this manner also. So this one only I am showing here for you. So 135 cycloheptatriene. The next one, what is this? Here we have some phenyl group. This can be identified. We have already seen this is known as benzene group. This benzene, in this benzene again, if something is substituted in the sense on the carbon. If you have benzene, up to here only we can identify that as benzene. But something else is there. Here we have first, second, third. Okay, numbering we should give in another manner, no? Numbering should start from that side because functional group is there here. So first carbon, second carbon, third carbon, fourth carbon. This is butanol. Why I am counting the number here only? Why not in benzene ring? Why not in phenyl ring? Because functional group is not there here. Compare with you compare with the OH, double bond, triple bond is not given much priority. So OH is there, butanol, it is identified as butanol, and phenyl ring is identified as a substituent present on second carbon. If that same OH group is there in benzene ring, in phenyl ring, we'll be identifying that as the main compound, and that butyl group whatever is there, that is attached to this. But we are not going to do in this situation. This is identified as butanol, 1-butanol or butane 1-ol, and on second carbon phenyl group is there. On second carbon phenyl group is there. So 2-phenyl 1-butanol or 2-phenyl butane 1-ol. Okay. Then what is this? Here how many carbons are there? First thing we have to do like that. So longest chain rule, that we have to remember. Many number of branches it should have, that also we have to remember. So here altogether we have 5 carbons. But if I count like this, what happens, children? 4 will come 2 times, because 4 we have to write, no? So instead of giving the numbering in this manner, we have to give the numbering from right side to left side. Right side to left side means I want to give the numbering here like this: 1, 2, 3, 4, 5. So 5 carbons are completed. On second carbon 2 methyl groups are there, fourth carbon 1 methyl. So 2,2,4 dimethyl pentane. 2,2,4 dimethyl pentane. Sorry, trimethyl. 3 methyl groups are there. 2,2,4 trimethyl pentane. Then what about this? Again you start counting the number of the carbons. How many are there? Just try it, children, once. Okay. Yes, 5 carbons are there. Then substituent is present here. Substituents are there. 2 substituents are there. So what we'll do? From any side we can count. First, second, this is third, and this is the fourth one, fifth one. And on third carbon we have this substituent. 2 carbons are there, no? So ethyl. It is identified as ethyl. So 3,3-diethyl pentane. 3,3-diethyl pentane. Okay. So some more examples we'll discuss in another session. Up to that time, you just practice and ask your doubts in the comment box. Okay.